All right, hello everybody. In this recording, we're going to be going over question 3 on the discussion, Scarlet coin. Let's begin by reading through the text of part A and the code itself, right? So it wants us to give an O bounded runtime bound as a function of n, where n is a sorted array length. And Scarlet Koi takes in 4 different parameters. The first one is an integer array, sorted array, which we're going to assume is already sorted for us. We're also going to take an integer x, which is the integer that we're trying to find in the array. Then a start integer, which is the starting index, and n, which is the ending index. And so generally start will be 0 on the array and the n will be length minus 1. Okay? So give it a second to run through this code and think about just how exactly it's going to run just for yourself. All right, now that you have done that, let's break it down together, right? So first of all, we have this if statement, which is checking 2 different things. Either start is equal to n, in which case we are just looking at one element basically, or start equals n minus 1, which means we're looking at 2 elements. And so in either of those cases, we're just going to return whether or not start is equal to the number that we are looking for, right? If that is not the case, then we're going to do something interesting when we break essentially this array into half, right? We're going to find a mid index where mid is equal to the halfway point between start and n, rounding down. And then we're going to check to see whether in this first line, we're going to check to see if that mid index contains the element x that we're looking for. If it doesn't, we're going to break this into 2 halves, right? This first half is going to we're going to use our original start, we're going to use mid as our ending index. And then the other half, we're going to treat our mid as a start index and use our original end index. And so that's very abstract, but let's break it down, right? And this is important to know because essentially the first step to solving any of these problems is to first understand how the function works, right? And so let's take a look at this really small example that I've created for us, right? This array is sorted 0 through 4, and we also have a start equals 0 and an n equals 4. And so for the purpose of this demonstration, let's not even consider x, right? Because if we find x, then our function terminates, right? But in this example, we're just looking for how exactly our function is going to run when we just run it normally, right? So start is here, 0, n is equal to 4. The first check we're going to see is this if statement, right? If start is equal to n. In this case, obviously it's not. So we're going to move on and we're going to create mid. Mid is equal to 2. And so when we go to this return function, the first thing we're checking to see is whether or not mid is equal to x, right? And so because we have checked this number, I've bolded it to make sure, to help us understand the pattern of what exactly we're going to be checking, right? Then we're going to break this function in half like this, and we're going to run the left half first, right? And so once again, we're going to do this if statement check. That is obviously not true. Then we're going to create this mid, which is the halfway point, which is equal to 1. And so we check this. And then once again, we break this into half again, right? We have this start and n and another start n, and we check the left side first. And so now start is actually equal to n minus 1. And so therefore, sorted array start equals x. We're going to check to see if this index, the start index, is equal to x. And so we bold that as well. And so now, because we've essentially exhausted this left side, now we're going to return to this branching off point, and we're going to check the right side instead, right? Start is equal to 1, n is equal to 2. And then we're going to recheck this 1 function here because start is equal to n minus 1, right? And so now that we've exhausted this right side, in essence, we've completed this left half of the tree, right? And so now we're going to return all the way to the original splitting off point here. And now we're going to look at the right side where start is equal to 2, n is equal to 4. And we're going to repeat this process where mid is equal to 3, and then we break into 2 once again. We're going to check the left side and then the right side. And then in the end, that is kind of how our function works on this specific example, right? And so now we can kind of generalize this process. Hopefully, like we've begun to see some patterns, right? And we can begin to generalize them into like a very large array, right? And so this is, in my opinion, a really great way to visualize what exactly is happening here, where we have taken this sorted array and I've broken it into essentially a binary tree, right? As you can see, as we move left to right, like this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I've just put it into this hierarchy, so it's easier to see what the pattern is, right? And also, I mean, before I guess expose what the pattern is, take a moment to think about what the pattern is for yourself. In what order are we going to check each of these individual elements? All right, let's break it down. So the first thing we're going to check is the middle, right? And then remember, like we did before, we're going to split this in half, and we're going to check the left side first. And we're going to check the middle of the left side first. Then once again, we're going to split it in half, and we're going to get this small subtree right here, and we're going to check the middle first. And then we're going to go to the left side and check 0. And so now, because we've exhausted this left branch in this smaller subtree, we check the right branch, which is 2. Then because we've exhausted the left branch of this smaller subtree of 0, 1, and 2, we're going to go to the right branch, which is 5, check left, 4, check right, which is 6. And so now we've completed this entire left side. We're going to move on to the right side, which is 11, then 9, and then 8, and then 10. and then 13, 12, and 14, right? And so as you can see here, this function is going to check every single element in the array in order to find x, right? And so now that we understand how this function works, right, we've created this pattern essentially that we can apply to any array. We can now start to think about its runtime, right? And specifically, we want to find its O bound, right? And what does O refer to? O refers to the lower bound of the function's runtime. And in order to find this, we're going to construct a quote unquote worst case input and find the runtime of that worst case, right? And so let's think to ourselves, what combination of X and a sorted array can we give Scarlet Koi in order for it to run as long as possible, right? And so notice is that if we give them any array and we set X as the rightmost number, in order for Scarlet Koi to return to check to find X, it's going to have to run through all of these numbers first, right? For example, in this example, right, if we give the number X equals 14, in order to find 14, it needed to check 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 first, right? And so therefore, we'll notice to ourselves that the O bound runtime is proportional to the length of the array, because in order for us to find the rightmost element, we need to check every other element first, right? And so therefore, one last thing we should check, is this really the worst case scenario, right? And the answer is yes, because, and the answer is yes, this is the worst case scenario, because once you have checked this rightmost element, the entire function terminates. So there's no possible way for us to get more runtime out of this, right? And so therefore, overall, we say that our O bound is equal to ON. All right, moving on to part B, why can we only give an O bound runtime and not a theta runtime, right? And so take a moment to remember what a theta runtime is, right? Theta runtime means that both O and omega converge to the same number, right? And so in order to check to see if we can give a theta runtime, we need to think about what our omega runtime is first. And so omega is the best case scenario, right? And well, what is the best case scenario? Let's consider a scenario where the first element we check is X, right? So if we go back to this example with 5, right, if we have X equals 2, what happens? Well, we get to int mid equals n plus this, we find mid equals 2, and then immediately we do sorted array mid equals X, and we find that is true. And remember, short circuiting, if we find this is true, then our function just ends right there, right? And so the best case scenario that we can construct is we give it an array of any length, and then X is equal to the number, which is in the exact middle, right? Which mid gives us, right? And so in that case, we have a runtime of 1, right? It is constant because instantly we are able to find the number. And so that implies that overall we have omega is equal to 1. And if you'll notice, well, omega 1 and on are not the same. They do not converge. And so therefore, we cannot have a theta bound. That is essentially like a definitional thing that you should know. Right. All right, and that was Scarlet Koi. Let's give a quick recap of what we've learned and what we can take away as general trends for when we take tests, right? So Scarlet Koi is a really good example of a question where you are given a function and then you are given this runtime, right? It's almost guaranteed that there will be at least one, if not multiple questions on your next midterm that have a very, very similar structure, right? And so remember, when we deal with questions like these, there are basically 2 steps we want to do. The first important step is to understand how our code works and how that runtime is related to n, whatever n in that context may be, right? So I think Scarlet Koi is a really straightforward example of this kind of question because it doesn't really play tricks on you, right? If you really think about it, you could probably solve it without drawing any diagrams. However, I've seen past exams that are extremely tricky when it comes to this, where your intuition screams at you like one answer, that is just completely different from what the actual runtime is. And so the number one way of knowing whether or not your answer is correct is to draw out a diagram. If you draw out a diagram and you check a bunch of different n values, then you can very crystal clear see the pattern of what your runtime is going to be. And that is almost always the best way to approach this kind of question. Then the second step, once you have understood how your function works, is to understand the differences in the different types of run bounds and what exactly they're looking for, right? So specifically, you want to know what O, omega, and theta are asking you for, right? O is a worst case scenario, omega is the best case scenario, and theta is when the best case and worst case converge into 1, right? You'll also want to understand the syntactical difference between what O, omega, and best case and worst case are. I don't have time to go over that in my video, but If you're unsure of what that is, go and check the first video. I know that Nadia did a really good job of explaining that. So yeah, definitely take a look at that in order to prepare for the course. But overall, I think Scarlet Koi is like a great template, and there are definitely lots of other practice exams and questions that you can find on those past exams that are going to give you a similar experience. And so definitely before your next midterm, make sure to really understand this format of question. But yeah, that should do it for Scarlet Koi. Thank you all for listening. I'll see you in the next video.